So tonight what we're going to cover is Module 3, Unit 5 and 6, and Module 4, Unit 1. Unit 5 is Management and Monitoring, Unit 6, Cloud Virtualization, and hopefully some of the terms will be familiar because you're using cloud computing when you're doing the labs and virtualization. And then network sites, what we want to do is site and some things that hopefully aren't as detailed in the HTTP and those sorts of things. So with that, let's start with the first one is use the objectives, use network monitoring utilities and load throughput testers to identify performance and connectivity issues. What we're going to do here is to have some utilities to test our system so that we can know what's going on with those systems. Collect and analyze system history and event logs plus interface monitoring net metrics. So, and this one, again, what we have is just a matter of this one, identify or doing logs is a big part of it. Identify the features and vulnerabilities of remote administration and terminal services protocols. Some of them are really good, some of them are really dangerous. So what we want to do is look at those things to see what goes on in the system. So identify the vulnerabilities. We're going to find that, again, that some of these remote access utilities are really good and some of them are really vulnerable. Start out with baselines. A baseline is what we want to establish so that we know what normal is. What it is a usage, I guess is a good word, is a basis for comparison in the future, because we'll put a network in and it's going to work really, really well for what we have because we've done a good job of baselining it to start with. But over time, the system grows and the system grows and the system grows. And one of the things that the baseline can tell us is when it's time to update. One of the jobs that I had, one of the things that we monitored were Citrix licenses because we were using a Citrix farm to do databases, and we had a whole bunch of people in different medical locations would get onto those things. And what we needed to know was what was our maximum usage, and as we monitored this thing, we could, and they hired more people, obviously grew and grew and grew. Then we had the data to go to management and say, hey, we need more of these licenses so that we can continue to do business. So baselines are going to do that, tell us when to update, where we have problems. We have some things that we just know what happens because, or that things are bad. Oh, the internet's slower, this is slower, that's slower, particular service slow. Baselining will help you show with data what's going on with the system, not with what we think is going on. So they're going to help us to know when to upgrade hardware and software if we need to reconfigure the network, and that may be a way around it too. Install new devices, change if we have a change in access and change in server roles. These things, if we make changes to the network, we need to look at it too to see what goes on. What did our changes do to us? And then we have thresholds. Thresholds are levels that we set that we want to get messages, that we want something to trigger to tell us that poor performance is going on. So we get these alerts, and they can either be emails or they may be SMS messages. We used to have the same place where we remind us of these other things. We had the piece of software called What's Up that would monitor the servers, and if anything happened to them, if one of them went down or if one of them rebooted or anything, it'd send text messages to us to tell us what was going on with the server, so that you could get up in the middle of the night. You get all these text messages in the middle of the night telling you that your server had just rebooted. And if it rebooted and came back online, first I'd get, I think, like 4 or 6 text messages saying that the server was down, and then I get 4 or 6, whatever it was, messages saying, hey, the server's back up, and it's really good at 2 o'clock in the morning. But those things happen. When do we want to trigger an alert, and what do we want to do with those things? A bottleneck, pinch points, bottlenecks like the neck of a bottle. It's going to restrict flow. We have lots of bottlenecks in networks, or we can have lots of bottlenecks in networks. If we have we talked about switches and hubs. If we had a whole bunch of high-speed switches and one hub in the system, the hub's certainly going to slow us down, and that's going to be our bottleneck. So it's going to pinch points that cause the whole system to underperform, and typically the bottleneck is going to be outside the computer. The computers are relatively fast. Even old computers are relatively fast today. Could be an underperforming device or link. It could be an indication that a device is failing. So all of those things are useful to monitor to see what's going on. An overactive user or application. If we had a NIC that's failing, a noisy NIC is going to put a lot of traffic on the network. If we have a user that's downloading all of his movies at work, then we're going to hopefully be able to do that. Poorly scheduled application updating services, and again, a personal experience there. When I took over a network, the Windows updates were already set up, and one day one of the people in charge came to me and said, my computer just rebooted. Do you have any idea why? No, not really. Let me go look at it. What I found out was that the updates had been scheduled to go on Friday afternoons during the middle of the workday, and that they had also been configured to do an immediate reboot. So things like that can cause issues if we had done these updates on something that was in line and restarted the system, or if we restarted a server in the middle of the workday. Those things could cause us some issues. Different utilities, and there are a number of them that they talk about. There's a number of free utilities that you can get. Health monitoring, a couple of free ones. One of the ones that I kind of like is SpiceWorks. It's free. It'll give you an awful lot of information about your network. Nothing else that's kind of fun to just play with. If you go on as an administrator, it'll tell you what softwares are on the machine, how much hard disk space is available, all sorts of things, inventory of it, so that you can see what's going on. You can actually monitor all of the users' machines to see if they're adding software, for instance, or if they have the ability to install software. Performance monitors. Performance monitor is not a kind of thing. There are other performance monitors, but performance monitor is a Windows built-in tool that we can look at what's going on with the system right now. We can also configure it to save the data so that we can put it together later for analysis. And the one I was talking about, the licenses, what we did was a sample every 5 minutes of how many Citrix sessions were in progress, and save that to a spreadsheet. And at the end of the week, we put together all of the daily spreadsheets to see what our maximums were, what times of the day, and when we started to run out of licenses, we did those things. Packet network analyzer. We've looked at some of those tools, and these things will tell us the top talkers and the top listeners. The top talkers, who is getting who's asking for most of the information, and the top listeners, who's getting most of the information. One of the tools that they talk about in the book is Nmap, and Windows has its own version, and it's called ZenMap. This is a ZenMap output. What I did was a couple of little things here. It sometimes can take, and I'll run a scan here real quick in a minute, but I scanned my little network here, and we can look at, we should be able to look at what's going on here. Ports, here we go. What's open on each of these systems. This one has a whole bunch. The red dots say they're closed. This is actually a Windows workstation. These are all the services that are available, but all the services on this machine are closed, and that's what the red dot means. As you go through, we can see port 23 here, 8080, and on down the line. This website here has port 8443, 8080 and 8443. 80 and 443 we know HTTP and HTTPS. 8080 is generally considered a Windows proxy address. I don't know what they've got that up there for, and HTTP alternate for the port 8443. It'll give you a look at the topology of how you're connected to these systems, and we can get some host details. It typically says the accuracy is a Motorola Surfboard cable modem is what goes on the two here, and that's exactly probably what that is. This one didn't, the Windows machine didn't pick up, which kind of surprised him because typically it'll tell you that it's a Windows machine. This is the router. It's a Linux based system, and as we go on down, these are tablets. I think I won't swear to it because I don't know what I haven't looked to see what all the addresses are on this thing. And then we can look at the services that are available on this system. If we go by down domain, it'll say it is or it isn't, and this is 150. This is the Windows machine, port 53, TCP unknown, and we know that port 53 is DNS. So you can get a lot of information here. You can also run this thing from the command line if you don't. What it has is some pre-configured scans that we can go in and use. It's a handy tool. It's one that you may want to, on occasion, run against your own network from outside to see what, in addition to NetStat, to see what actually is open, which kind of systems is it looking for, have opened up ports that are will accept connections to your network. The other one is load testing. Port scanner, I see I got ahead of myself. Port scanner, load and throughput testers, stress tests. I found a website, if you're interested, it's called loadimpact.com. Looks like it's in Australia. You can actually load test your website to see how it stands up. They just keep adding connections to see how much you can actually do with these things. Port scanners tell us what ports are open on a system, and the open ports are those that are waiting to accept connections. Speed test sites, you've probably used speedtest.net, a number of them out there. What kind of connectivity do we have? I test semi-regularly when I say, oh, this thing's not working right, to see if they're actually giving me my bandwidth. But all of these things, these tools are available, and that's what the labs today are mostly about, is being able to get to do those things, to use those things, to see what some of them look like. Logs are also a really important part of managing what's going on. Logs can often tell you where to start troubleshooting your system. I will be the first to admit that I'm not the greatest in the world at looking at logs. I usually fool around and flail around for a little while, And then after I flailed around for a little while, I say, maybe I should look at the log. And the log says, oh, this didn't start or that didn't start. And if this particular thing didn't start, that may have been what was causing me my problems. And the log types, and these are Windows log types, are system, event, history, and performance. The system is what's going on in Windows itself. It's going to give us some indication of the Windows system. The events, different events that go on, history, performance. When we talk about log management, up until Windows 7, all Windows logs resided locally on the Windows machine. After Vista, Windows 7, and we'll say Windows 7 because Vista is probably one of the worst things that they ever did. We were able to subscribe to logs so that we could get information on a single machine. We could have a single log server that went out and got the information from the different computers, the different logs, and stored it centrally. Linux has been able to do that for a long time with syslog, and you could create a syslog server. When you do routers, Cisco routers don't really have the capability to store a very large log file. And what you'll need with them, if you want to be able to do very much with them, is a syslog server. And there are softwares you can run that on Windows too, a syslog server. There are a number of syslog softwares that are available if you want to use them. The security information and event management consolidates and forwards different things, IDSs, anti-malware. What they were trying to do with these things is to detect attacks. And the alarms and alerts down here, email and SMS, kind of talked about that before. You can usually configure these things to either send you an email or send you a text message, whichever you prefer. If it's available, I would think that probably the SMS, the text message would be better, unless you have something that tells you every time you get an email. Sometimes I see them quickly and sometimes I don't see them quickly. The performance and metrics, what we want to do with these things is analyze trends, and that's the whole objective of all of the monitor, of seeing what's going on if we can detect attacks. But what are the trends? Are we getting to the point that we need new hardware? Are we getting to the point that we need more capability in the system? And then these are the things that can help us do that. Log management is going to be a big part of this. I know I'm stuck on logs, but if you don't look at the logs, there's no need in having the logs. And if you don't look at the logs, I'm still on the last slide. If you don't look at the logs, you won't know what's going on, and they grow. I mean, they don't grow real quick, but over a couple of years, went back into a server that we didn't really monitor a whole lot. We just ran and looked at the log files, and you get log files of a gig or a couple gig big, and that's a lot of data in a log file. You can see frequently when somebody is trying to attack you, it's handy to look at those things. So we want to look at trends, and then we're going to have graphing, and graphing is the way we want to do it. I talked about that for when we were trying to show how many connections that we needed, that we saved them and we configured the Windows performance monitor to save the data I think it was every 5 minutes, on how many of those particular sessions were open. And then we would graph them at the end of the week and maintain the graph so that we could see what the trend is. As the trend goes up, you can project when you need to buy more licenses. We didn't really want to buy licenses that we didn't need because they're not inexpensive. And that particular software, you have to buy 2 licenses. One, you have to buy a remote desktop license from Windows, and then you have to buy a Citrix license from Citrix. So we wanted to be sure that we needed them before we actually got there. Server and appliance monitoring, what are we going to look at with those things? Bandwidth, network device, CPU, memory, storage. We can, again, monitor all these things. How much bandwidth is there? How much activity is there? What time of day is the activity? When does it slow down? Does it slow down? What's the CPU utilization? And what we find out is that CPU utilization is usually on average pretty slow. It jumps up, it peaks every once in a while. It'll jump up for a few seconds. And what you need to be sure that you do when you set up your alarms and your alerts is that you don't let the peak value trigger those. You may want to be at 80% or 100% CPU utilization for 3 minutes before it sends you an alarm, because if you set it up, if it goes to 100%, send me an alarm anytime somebody opens something, it's going to jump to 100%. How much memory is being used? Do we have a memory leak? And what a memory leak is when an application starts, it uses memory. When an application closes, it's supposed to give that memory back. If it's not given the memory back, it has what's called a memory leak, and it keeps taking it out of the memory pool. Storage. If you've ever run out of storage on a Windows machine on the operating system, you know that Windows cannot operate without disk space. And if we run out of storage, probably not going to be a real good thing for our future. Again, monitor the storage as you're using it. Why are you using it? Is somebody using an excessive amount of storage? I've seen those things happen before too, and you go and look and, oh golly, somebody really is downloading movies and storing them on your server in their home directories. You need to monitor those things. What's going on? Who's using how much of the things? And storage is pretty cheap, and the disks are getting bigger and bigger and bigger, but what you don't want is to just have anybody use as all of it as much as they want, or put things on it that they shouldn't be having. And talk about interface monitoring, link status, whether the interface is working, is up or not, or is down, and if it resets, the number of times an interface has restarted over the counter period. How many times does it restart? What's the speed? Are we getting the speed that we expected from it? What's the duplex status? The utilization is going to be the percent utilization of these things. How many errors do we have? And the errors can be significant if a device starts to fail. And book says that in general terms, error rates should be under 1%. Very high error rates may indicate a driver problem. They also may indicate a hardware problem, or a hardware problem that's getting ready to happen. Discards and drops. An interface may discard incoming or outgoing frames for a number of reasons, including checksum errors, mismatched MTUs, packets too small or too large, and the too large and the too small packets, too small and too large, let's go with them that way. The too small are called runts, and the too large are called giants. And those will get dropped because the system doesn't know what to do with them. SNMP is Simple Network Management Protocol. What it has is software. It has agents. We have an SNMP server, and then an agent that's on a device. And what I've used it for principally in the past is to monitor network traffic, to monitor servers, what's going on with the processors, what's going on with the storage. What has to happen is you have to have an SNMP capable device. If you have a switch or a router that's SNMP capable, it can send you information. And it sends that information to the SNMP management system. This is one that there are a number of softwares that are available to monitor things. One of the easiest ones to use, and I don't know if they still give you a free version, is PRTG. You can monitor your networks, you can monitor what's going on the server, although you can monitor what's going on your Windows systems with the Windows Performance Monitor. You can set it up, as long as you're an administrator, you can put those objects into a central server and monitor everything that goes on the system. So the agent is a process on a device, and it maintains a database called a MIB, a Management Information Base, and each parameter is called an OID. The management software can get something, can trap something, or can walk something. It queries for a single OID, a single parameter. A trap, the agent informs it if there are notable events that are going on. A trap, actually, you can watch things. A walk is when you walk through what's going on. You get the next parameter. So they move up and watch over those things. PRTG is a commercial one. There is an open source one called MRTG, which you can also use to monitor your systems. Agent properties, if you go into these things and configure them, and this is what would look like on a Windows server and the services that we're going to do. We have a community name, and the default community name is public. SNMP is a very simple protocol, not an extremely secure protocol. It's a very simple protocol. It has a secure version. There are 3 versions, SNMP 1, 2. Use plain text. SNMP 3 supports authentication and encryption, which hasn't happened in the systems before. If you do use it and somebody has got a packet sniffer on the network and they have port mirroring or a hub, we've got to go do all those things, because remember, a switch isolates everything, and this is not network traffic. Then you'll be able to see the system. We had to find out what the community string was that was being used in our network one time, because nobody would tell us or they didn't know. So what we did was put a hub in, put Wireshark in, and we had the community name in just a few minutes. And after we did that, then we could configure SNMP to monitor the network traffic. We were using MRTG, but we needed the community string in order to set that up. The properties we can use these things are read-only or read-write access, and you probably want to set most things up to read-only, because the only people that should be able to do read-write are administrators, and then we can do traps, and again, traps is where we're going to get the information from these systems. And SNMP version 1, version 2, SNMP 3 is a secure system. And then talk about access control list. Access control list tells us what we can and can't do when we do these things. Telnet, it's a command line terminal emulation software, connects to the client, uses port 23. It's plain text protocol. It has no security. If you have a sniffer on the network and you can see all the traffic, if you know the same thing, port mirroring, or you're on a hub, you'll be able to see, or a man-in-the-middle attack, you'll be able to see everything that goes across Telnet, including the passwords. So it connects the client to a remote server. The remote server is a daemon. You have to configure the system to accept Telnet connections. Windows comes with both the client and the server disabled. You can enable either one. What you effectively do when you use Telnet is connect via that long piece of wire, that connection, a keyboard so that you can give commands at the remote system. Handy if you need to do remote configuration of routers, for instance. You can telnet to them and use those things. And again, it's port 23. A lot of things down there in the 20s. Secure Shell is Secure Shell is a better answer for this remote connectivity because it is secure. It uses port 22. We're getting them all right down there together, 22 for SSH and 23 for Telnet when we go through these things. It tunnels other traffic over SSH, and we can use Telnet SFTP, Secure File Transfer Protocol, because FTP is also a non-secure system, and it supports port forwarding. Windows Remote Host, WRM and WRS, are the two processes on Windows that's used to set up the logging, the receipt of logging from one to the other so that you can monitor the systems. Remote Desktop Protocol, RDP, is a GUI. Remote administration uses port 3389. It's just like you were there. You see the whole desktop in the graphical user interface. There are usually two things on a Windows server anyway. One is remote desktop, which is one at a time, and the other one is remote desktops, where you can set up multiples of them. Remote desktop is available to go to a server by Windows. By default, you get two remote desktop connections for management to go to a Windows workstation, one remote desktop. These sessions can be encrypted, and network level authentication says that the workstation as well as the user would have to be authenticated, and it just makes it a little more secure, cuts down on some man-in-the-middle attacks, and that is configured on the system itself, whether we want to allow any system, and network level authorization means Windows Vista, Windows 7 and above only. That means that you couldn't, if you set this, you couldn't remote desktop from a Windows XP machine. It's really handy, and generally speaking, that's the way you're going to do most of your management, because what you're probably going to have, and what we had was, I don't know, 5 or 6 servers, and we didn't have keyboards on all of them. What the management generally was done was via remote desktop, where you would log into the server using this and do all the management there. When you log in using RDP, remote desktop, and you can log in, you can get onto a Windows machine from a Linux machine using the remote desktop protocol, RDP protocol, port 3389. It's a handy, very, very handy tool to have to access something remotely, and you may or may not have done that. There are a number of softwares that are available that will allow you to do those things. If you have friends or parents that aren't real good at it and you need to get onto their systems occasionally to do things, TeamStream is a software that's available for private use for free. It's not available for corporate use for free, but it is available for free, and it gives you a remote desktop session, and it typically will go through a firewall. You can either set up, if you have a bunch of machines that you're managing, private machines that you're managing, like your friends, you can have a login where you get them all, or you can have an individual key that is used for each session that we do. So in the review, use the network monitoring utilities, load throughput testers, and identify performance and connectivity issues, tools to see what's going on the systems, on the network, and on the individual computers and routers. We can monitor utilization on all of these things. Big one would be network bandwidth consumption. Is somebody doing something they shouldn't? back to the top talkers and the top listeners. The top talkers, obviously, who's sending the most traffic, and the top listeners, who's getting the most traffic. Collect and analyze system history and event logs plus interface monitoring metrics. Log analysis is not any fun. It's boring. It's a pain, but it is something that does need to be done. And there are utilities that are available to help you do that. Identify the features and vulnerabilities of remote administration and terminal service protocols. The big vulnerability is going to be the non-secure ones, the SSH, and then using a secure remote desktop system. And TeamStream does allow you to establish a VPN and manage it through a VPN, so it can be secure, just as RDP can be secure. The protocol itself is not going to be secure until you take other steps to make it that way. So with that, are you ready for the question time? You guys ready? Gathering statistics regularly allows systems administrators to identify bottlenecks. Why do you want to do this?
Pinpoint the issue.
Pinpoint the issue? Other reasons? That's right on the money, but what if we need to upgrade, things like that? What if I'm running out of licenses?
Oh yeah, that's true.
I mean, what you said is absolutely on the money. Identify issues. Where is the issue?
Restrict the workflow, I guess.
Yep, all of those things. What would be the purpose of configuring thresholds in network monitoring software?
Triggering alerts.
Get an alert, just like I talked about with and it really was. I'd wake up in the middle of the night and this thing would be screaming at me every time one of these text messages came in. The servers were rebooting. It was telling me that the server was down, and then it told me that the server was up. Good, I can go back to sleep now. But it will give you alerts with what's going on, and you have different softwares, different capabilities of different softwares, and those are the ones that you've got to, those require investigation. There's so many of them out there, and they keep multiplying more and more and more every day. What is a top listener in terms of network monitoring?
Someone who's receiving the most traffic.
Receiving the most traffic. What is the purpose of a port scanner? That was the one I showed you.
Reveals a snapshot of how applications are using the network.
Yep. What's running? What ports are open? What sort of log would you inspect if you wanted to track a web server access attempts? And there's a whole bunch of them. Can I do this one? History, security, audit, on and on and on and on. The web servers have lots of logs, and they have their own logs, not just the standard Windows ones. And sometimes you need to go in and see what's going on, who's connecting, who's trying to connect if you have logins on those things. What is the purpose of SIEM, S-I-E-M, Security Information and Event Management?
To consolidate the server.
Yep, consolidates the services from the alerts to try to help you determine when an attack's taking place. You suspect that a network application is generating faulty packets. What interface metric might help you diagnose the problem?
Bring me some pizza back. I'm hungry. Yes.
Log analysis.
Log analysis, yeah. What if the specific things that we probably want to look at are the errors, the discards, and the drops. When you start doing those things, you're going to generate more errors. And if you look at servers, routers will actually tell you how many errors they have if you go back and look in them specifically. But if you have SNMP enabled, configured so that you can display it on a desktop with in a management window somewhere or on a management machine, you're going to see those things a lot quicker. What TCP/IP application protocol is associated with TCP port 23? And this probably is one that they'll want you to know. Telnet. I heard Telnet back there somewhere. Describe some uses for SSH.
It tunnels other traffic.
Tunnels other traffic. We can all those generally SSH is going to allow us to make those things that we talked about, Telnet, RDP, those things that were insecure, we can configure them in a secure manner. Okay, tonight, lab nights, also lab nights every night, but on the schedule that I have right now, what we want to do is lab 14 and 15, and combined there should be about 70 minutes, so that'd be an hour. What is it? 7:45 roughly in Dallas and 6:45 roughly in Colorado. So let's come back in an hour and 15 minutes and do the next lecture. Will that work? Lab time? I'm going to be here monitoring. What we want to do for the next few minutes is talk a little bit about virtualization. Again, it shouldn't be anything dramatically shocking to you because you've been using virtual machines for all of your labs. As a matter of fact, you've been using virtual machines inside of virtual machines, and that's what Hyper-V allows to happen because you always start the Hyper-V manager. But the objectives for this one: identify the technologies used to implement virtualization, describe the different types of virtual network components, NICs, switches, routers, and firewalls, understand the use of storage area networks and technologies underpinning them. And one of the things that I think you'll need to know is the difference between a storage area network and network attached storage, a SAN and a NAS, and unfortunately they use the same letters, just reversed them. Understand the use of virtualization and cloud computing to provision on-demand cloud star as a service. But there are lots of services. There are a lot of people providing cloud services now. Amazon is one of the biggest providers, and Microsoft's becoming one of the, I think lately, maybe the biggest provider of cloud services. So with that, the virtualization technologies, hosts are the computing platforms. The hosts are the machines that the virtualization software is stored on. It can either be part of an operating system, Windows or something like that, or it can be what they call a bare metal. VMware has a virtualization computer or machine or software that only does virtualization, so it would be a bare metal platform where you install it. Now, hypervisor is something that controls access to resources, networking, and security. What that means is, what does a virtual machine really do? Virtual machines share the hardware. They use individually the hardware. So as a group, we get a much better hardware utilization by using virtualization. The biggest bottleneck in virtualization is going to be disk access. You get a very high utilization of memory, you get a very high utilization of CPU. Disk access is the thing that really slows things down in the virtualization world. The guest operating system are the virtual machines themselves, and I have this little slide here to kind of show the difference between the virtualizations. There are two levels of virtualization, type 1 and type 2. Type 1 says native bare metal. What happens in these things is we have an operating system, and the hypervisor runs between the operating system and the hardware. A type 2 is called hosted. This would be like a VMware workstation or Windows virtual PC. All of these things that run the hypervisor, the virtualization software run on top of the operating system. So they're not going to be as efficient as this one here that's not on top of the operating system. It's a matter of what you really want to do. Until Microsoft got the Hyper-V server running, this type 2 was what they use. They still have a software that'll run them in a web interface, which is kind of neat, kind of if you're trying to allow training to go on. So in the virtual networks, and you've looked at these things over here in the labs themselves that you've done. This is the virtual switch manager, but we manage different things. The guest OS can have one or more virtual network adapters, and you have seen those. And the network adapters can be configured one of three ways. They can be configured as attached to a switch, which is internal, and then they will communicate with the VMs, but they can also communicate with the host. External, where they're actually bound to the NIC of the machine that's there, or a private, and the private creates a switch that's usable only by the VMs. They can't communicate with the host. What you would typically do, or what I've done in the past, is we'll have let's say we created a network here and we had a bunch of machines connected to it, and let's say its network address was 192.168.3.0 network, and maybe we had another network down here that was 192.168.2. We wanted to keep these two separated. At some point we would have to have a router, and I'll draw a circle in here, a router that would have an interface that go to each of these networks to route between them. If we then wanted to go to the public network, we would need a separate NIC on the machine, the router, and the router in this case is going to be a Linux machine or a Windows server with two NICs in it, so that we can connect everything together while maintaining some semblance of separation when we do these things. So the guest can be connected to the VM-only network or join the host network, depending on how you configure it. The virtual switch is implemented by the hypervisor to connect the VMs in different types of networks. And typically what you do, or what we did, was we just create a network and then we would connect them. And when you've done the NICs on these machines, I think that you've seen that there's a drop-down box with several networks available that you can connect to: private network, public network, different ones, which depends on how many you need. You can configure them. I've never had, and I don't think, well, Hyper-V, the new one, we were using the web interface software, and when we got to 4 NICs, I couldn't put any more on the machine, and that's kind of a Windows thing there. You run into some physical virtual limitations, some limitations of how much hardware you can actually add to a virtual machine. The virtual networks will typically allow you to make them the DHCP server, so that you can automatically assign the IP addresses, the default gateways, and all the other things that you subnet mask, all the other things that you need to have an effective network. The virtual routers and virtual firewalls are going to be software running on a virtual computer. You can put all these things on a virtual network. A virtual router, again, you can use a Windows server machine, or you can use a Linux, any kind of machine with 2 NICs. Firewalls, Linux has a number of firewalls that will run on it. You can use them, or you can use the firewall on the Windows individual machines in order to protect them. When we did them, and it was learning how to configure Windows machines typically in classes, we didn't really worry, except for the firewall configuration in the labs, and didn't really worry a whole lot about it. We did have routers because you had to do updates and all those sorts of things, and they work very well for the virtual network. Software-defined networking, and what I want to try to do here is to use this little clever thing for network sharing, or video sharing. I found a video that explains this thing, and what I'd like to do is try to show the video first, and then we'll talk about it for a few seconds. But first I got to get to it over here, find it again on my hard drive. If this doesn't work, somebody text me and or message me and let me know it's not working, because I have posted this thing on the blog, so you can watch it there if this doesn't work.
This video will demonstrate a couple different ways a connection between a client and a server could be set up in a software-defined network. A software-defined network attempts to build a computer network by separating it into 2 systems. The first system is the control plane, which provides performance and fault management via NetFlow, IPFix, SNMP, and other standard protocols. It typically handles configuration management of the
This thing says you're not seeing it. Are you seeing it or not? Did everybody leave me?
No, I'm
No, I
here.
can see it.
Can't
I can
see it or hear it.
You can or cannot?
Cannot
Okay.
see it
Okay, hang
or
on,
hear it.
hang on just a second. Let me try to do it the way I did the other night. As soon as I get my arrow back. The video sharing is a beta thing, and I guess it's not sharing. I have to turn it off, and the thing, it doesn't work.
This video will demonstrate a couple different ways a connection between a client and a server could be set up in a software-defined network. A software-defined network attempts to build a computer network by separating it into 2 systems. The first system is the control plane, which provides performance and fault management via NetFlow, IPFix, SNMP, and other standard protocols. It typically handles configuration management of the SDN-compliant devices and understands the network topology. Loaded with these details, the controller can process connection requests based on desired requirements, such as QoS levels. The controller can also perform unique management between devices. The second system is the data plane, which is responsible for forwarding.
Where's the video? I hear somebody playing it, but I don't see it.
To be reliant on the controller to make forwarding decisions, or make the decisions on their own. The control plane configures connection paths, or flows, into the data plane through the use of a control protocol. The control protocol is used by the controller in a software-defined network. perform important functions such as connection setup. When a host attempts to communicate with another host over an SDN, the first packets from the client involved with the new flow are used to determine whether or not a forwarding decision can be made locally by the switch, or if the switch needs to ask the controller what to do. If the switch determines that it must ask the controller, it will do so
Okay, I don't see it.
using the controller.
Yeah, Larry, it's actually showing waiting to view your screen.
If the flow should be granted. If allowed, details about the flow could be entered into the controller's connection table. The controller
I don't think he realized that we don't see it.
the switches in the best path along the data plane.
Yeah, you're right. I'm sorry. Because I have to take my headset off when I try to show it.
Yeah, we don't see
I
it. We
see.
just,
I'll start it over. I see what happened. Because that video playing that didn't work, turn my screen share off. Let's start it over. Let's try it now.
This video will demonstrate a couple different ways a connection between a client and the server could be set up in a software-defined network. A software-defined network attempts to build a computer separated into two systems. The first
We can't hear it.
which provides performance and fault management via NetFlow, IPFix, SNMP, and other standard protocols.
nope, he just muted it.
Understands the network topology.
Wow.
Loaded
Larry, you muted it.
No, I didn't.
based on desired
I can't hear it.
QoS levels.
Now I can hear it, but it's low.
Management between devices. The second system is the data plane, which is responsible for forwarding
There you go.
to the selected destination. Switches can either be reliant on the controller to make forwarding decisions or make the decisions on their own. The control plane configures connection paths or flows into the data plane through the use of a control protocol. The control protocol is used by the controller in a software-defined network to perform important functions such as connection setup. When a host attempts to communicate with another host over an SDN, the first packets from the client involved with the new flow are used to determine whether or not a forwarding decision can be made locally by the switch, or if the switch needs to ask the controller what to do. If the switch determines that it must ask the controller, it will do so via a secure channel using the control protocol. The controller decides, based on policies, if the flow should be granted. If allowed, details about the flow could be entered into the controller's connection table. The controller could then send instructions to program the switches in the best path along the data plane. Then the flow would be directed through the network. The switches may also tell the controller when a flow is no longer active. This removes it from the table. Centralizing some or all of the connection requests has several benefits. Because of the configuration policies in the controller, some connection requests could be dropped, such as DOS attacks and broadcast discovery traffic. The policies on the controller that are leveraged to make decisions on flows can be based on ranges of IP addresses, time of day, and other characteristics. SDNs also claim to overcome scalability issues. It is unlikely that a single controller would be processing all of the connection requests for all of the access points on the network. The issue can be managed in a couple of different ways that can coexist. The first idea is to break up the network into multiple control and data planes. Policies can then be synchronized across multiple controllers. Each controller still sets up connections end-to-end, even when another data plane is involved. A second way to unload some of the connection processing on each controller is to allow the switch receiving the initial connection requests to make some forwarding decisions. Allowing the switch to make most or a portion of the forwarding decisions provides support for environments that are not ready to commit 100% to a control protocol. Traffic analysis of a software-defined network comes in two major formats. Typically, the switches and routers in a software-defined network are SNMP compatible, and they can generally export some type of NetFlow or IPFix data. Even the controller could be set up to export flows from its connection table, ensuring that all details are available for network traffic analysis. SDNs have gained tremendous momentum because at least 6 of the largest networks in the world are supporting it. So, what are the benefits? The benefits of an SDN could lead to the ability to purchase inexpensive switches that have very little resident software and processing needs, centralization of the forwarding information base, or FIB, allows optimum routes to be calculated deterministically for each flow, end-to-end across the topology. SDNs dynamically respond to application requirements. SDNs optimize the utilization of the network without sacrificing service quality. SDNs can filter packets as they enter the network, and hence, these switches can act as simple firewalls at the edge of the network. SDN switches can redirect certain suspicious traffic flows to higher layer security controls, such as IPS systems, application firewalls, and data loss prevention devices. SDN switches that support the modification of packet headers will also be able to function as a simple, cost-effective load balancing device. SDN controllers can be clustered for fault tolerance and high availability. So, with all these benefits, why aren't companies rushing to deploy SDNs? When will businesses want them? Interest will increase when applications utilize the centralized control available in most SDN architectures, and when IT members can purchase solutions that allow them to properly manage software-defined networks. The good news is that nearly all of the hardware companies have announced plans to embrace it. Thank you for watching.
Okay, I didn't want to restart it. I guess I'm really loud now. The objective of that is not to make you an expert on it, but to give you an idea of what it does. And the whole thing that it does is simplifies or centralizes management and takes that really complex network and manages it. So the SDN applications define the policies on the control plane, which is what he said in the video, are abstracted to an application programming interface, and the network controller implements policies as a configuration. We have northbound for the network controller and southbound for the appliances. I think I've got another picture here. So we have all of the in the control plane was where all of those, I think I counted them, I think there are like 16 switches, which was supposed to represent network complexity. And then we have the application plane, which are the things that are trying to do something. Down here, the data plane, this is where the server was with the disk. So what this does is have rules about how to get from point A to point B and what can get from point A to point B. That's what he was talking about. They can help in the control of attacks on the network. That video, if you want to watch it where you can hear the whole thing, sorry, is posted on the blog netplusldc.blogspot.com. Storage virtualization. When you create a virtual machine, you create a virtual hard drive to install it on. Microsoft uses a VHD extension for their hard drives, and I believe that VMware uses VHX. I've worked with them, but I haven't done it in a while. But the operating system passes control of physically locating data on disks to a virtualized layer. What we're talking about here is virtual storage, and when we have a storage server, at least the Microsoft storage server, you have physical disks, and within the physical disk you create virtual disks to do the storage. Advantage to a virtual disk is if you need to move it, you just copy the file. Unlike if you need to move data from a physical disk, if you have an issue with it, of course that presumes that you can still get to it. The other advantage of a storage server in using this virtualization is data deduplication. If you have a bunch of users that have the same file stored in their hard drive, and this has to be exactly the same file, you could save a lot of storage space if they all pointed to one physical location, and that's what data deduplication does for you. It only keeps one copy of it, and everybody uses that copy as if it were in their own drive, as if it were their own copy of the thing. And to energy efficient storage hierarchies, here we have online, which are the disks that we actually use. Nearline are things that can be mounted tape or maybe a CD, DVD, jukebox, and then offline storage, which is something that has to be put into the system and brought up. And then they have this thing called MAID, or Power Managed RAID, and what that does is have some of the disks off. Not all the disks are on all the time. One of the things that we're trying to do here is save power, but we're also trying to save heat. Trying to save heat generation. Heat's one of the big enemies of networking, and when you get into a large server farm or something like that, getting rid of the heat becomes a really big problem, something that a lot of people take a lot of time to try to get the heat out of the system. I think they say the proper temperature for these things somewhere around 60 to 75 degrees. Generally speaking, if you're uncomfortable, your computer is uncomfortable. That's one of the rules that I've heard a long time ago. The storage area networks with direct attached storage, that's the hard drives or the SSDs that's actually attached to the computer, the ones that we use, the SCSIs or whatever else that we have on the system. Then we have network attached storage. And the differences in these, let's get that out first. File level access for network attached storage and block level access for storage area networks. Network attached storage just simply is directly attached to the network. There are a number of ways you can do that, but what you have is some sort of a basic operating system to manage this thing. So it's attached directly to the network, and there you can go buy those things and connect them to your own network, and you may have seen them where you hang a drive off. You can share files from these things, but they're separate from everything else. The other is a storage area network, and what it has is some controls here, and then it goes through an interface, and this shows a fiber channel interface, which are very expensive. If you want to experiment with this, there are available iSCSI, and this could as easily be an iSCSI interface, which would actually be running back here on the server. These manage the storage. The storage is not on the server. It goes through the fiber interface to a disk array back here, the storage area network. So the storage area network block level access is the actual physical location of the data. File level access is what we use to get our files, and that's what this does. This goes and finds files. This goes and finds individual blocks of data so that we can have some whatever sorts of efficiencies, because file levels, typically small office, home office, single box solution when we do these things. Down here we see block level with the fiber channel, and fiber channel would be an enterprise level because again, they're very expensive. They're very fast, but they're very expensive. A data center, multiple switches and devices can be used with it. Fiber channel and iSCSI, and I'm saying iSCSI because I really think you're probably more likely to see an iSCSI, which is an internet SCSI. It uses the SCSI protocol to send data across a wire. So instead of having a cable connected to your disk storage, you have a different cable. You have a network cable attached to it. But in these things, we're going to have both. We're going to have an initiator, host bus. This is going to be on the client server, and Windows 7, I think, on up has a built-in initiator. And then we're going to have target. The issue in the past, in order to be able to do these storage solutions, has been creating the target on the server. And the target on the server is basically a link or an interface, a connection interface, so that the initiator goes to the target, and you can configure the target to be multiple users, single users, whatever you want it to be. You can manage it wherever you want. And each of these hangs has a logical unit number, a LUN, and the LUN is what you connect the initiator to, so that you can get the information that's really stored on a virtual disk back on the system. We'll picture here we have an iSCSI initiator. Now picked ice again is it's the one you're probably going to get. It goes to a switch, and then the switch, the LUNs are configured over here on the drives, and the LUNs are going to connect you to virtual disks. One of the things while we're here on this switch that you may want to do, because it's Ethernet, and Ethernet, you remember, has a maximum size of 1,500 bytes. We may want to configure all of these devices to use jumbo frames so that you can get the data transferred quicker. The jumbo frames just means that we're going to have a much larger maximum transmission unit, somewhere around 9,000 meg instead of the 1,500 meg. Fiber channel over IP, SCSI, fiber channel over Ethernet, and all of these things use the same concept. Fiber, again, is going to be much, much faster, but fiber is also going to be much, much, much more expensive. Cloud computing and how we use cloud computing, and different ways to do it. The IT infrastructure, one of the things, elasticity and pay-per-use. Elasticity is one of the real advantages, that if you need more computing power, you buy more computing power at the time you need more computing power. If you're getting ready to go into the holidays and you expect to sell a lot of stuff, you go tell the provider, hey, I need more server, I need more of this, I need 14 more web pages in order to host my stores, and they do it, and you pay for it only in that time. If we weren't using cloud computing, then you'd have to increase your infrastructure, go buy the servers in order to provide that surge capability. And you can buy the surge capability, and then when you're done with it, you can bring it back to the lower levels. A number of providers in the cloud computing world out there. The types of, and that's what this one is the types of deployments. We have public, which means that you can be on a cloud with other users. Hosted private means that you buy a private network on these things, on the cloud. Public, you don't know who you're going to be on that particular cloud or network with. A private is if a company hosts its own cloud computing, and all cloud computing means is that we get to it via the internet. We share in the cloud. Dropbox is a cloud thing. A lot of GoDaddy and those places that provide web services are cloud. A community cloud is one that is shared amongst several different corporations, and you'll probably know who those corporations are. And the objective of this is that, you know, what kind of risk do you have? How do you want to set it up? Do you want to do in the private? You would actually be doing your own infrastructure. You'd just be creating your own cloud. The star as a service, the different things as a service: infrastructure as a service, network as a service, software as a service, platform as a service. How much do you need? Infrastructure as a service is the entire infrastructure comes from the cloud. Network as a service, you're probably going to get server and storage. software as a service. You can get software, and a lot of people do that with like web servers, where you go to the GoDaddies or the one-in-ones or a number of other people out there that provide that, and you buy a particular software, typically going to be a web site as a service, and then a platform as a service provides resources somewhere between the software and the infrastructure as a service, and those are, that's a real great definition, I know, but it is somewhere between there. Infrastructure is the entire system, provisioning your IT resources, servers, load balancers, storage area networks, the entire infrastructure. A number of people are doing this, and I guess that it's one of those things that everybody rushes into. You kind of got to be careful about it, at least initially, because we're presuming it's all going to work. But when it goes down, part of the Amazon cloud went down, I don't know, a couple years ago, and there were a lot of systems that were offline. You got to remember that when they do these things, these services will maintain backups for you, and they're going to have to maintain a lot of backup, because if they start losing data for individuals, then they're going to not have a lot of business. But that's available. That's where a number of processes are going in today's world. Virtualization, I've used virtualization probably for, I don't know, maybe 10 years, and it works really well, I think, in the training world. I know that some of you that don't think that the instructions are all that clear on the labs, but the ability to go in and configure the machines from wherever you are, if you'll think about it, really is pretty spectacular, because otherwise you'd have to go into someplace where those machines were in order to configure them. The other thing that you can do is build a much larger infrastructure for the individual students, so that you can do more things, and you can have more practical networking by using virtualization. You can build a pretty complex network, a pretty complex infrastructure for everybody, and allow them to work through all the connectivity issues that go along with these things. And with that, the technologies used to implement virtualization describe the different types of virtual network components: desktop server switches and PBX. All virtualization is software that allows us to share the hardware resources, which gives us better utilization for that hardware that we've bought. Understand the use of storage area networks and the technologies underpinning them, and that's going to be things like the iSCSI and the fiber channel. The storage area network, remember, was the one that was out by itself. The storage was managed through the servers, but the storage itself was a separate entity through a fiber channel or an iSCSI or something like that. Understand the use of virtualization and cloud computing to provision on-demand network as a service infrastructure. That's what the companies that do these businesses do for us. Okay, I'm going to quit now. We'll do the questions. What's a hypervisor? And I'm going to wait for you guys to answer. What's a hypervisor? We're never going to get done if you don't answer the answer. Okay, Antrell.
Manages the virtual machine environment and facilities interaction with the computer, hardware, and network.
Yep, you found it in the book, huh?
Yeah.
That's what it is. The hypervisor, really fancy word, just means that it's the thing that manages the virtual machines. And there are two types: the ones that run on bare metal that run under the operating system and the ones that run on top of the operating system. Virtual PC and VMware workstation, and VMware actually has a server that runs on in software also, but the ones that run on top are going to be not as efficient as the ones that really run in the Hyper-V type 1. True or false? It is only possible for VMs to be networked via a virtual switch.
False.
False. Possible to configure the VM to use either switches virtualized by the hypervisor or the network's physical switches, which you would be attaching to the physical NIC of the host machine. What is the function of a network controller? That's that thing with the video that some of it you saw and some of it you didn't saw. But what was that thing designed to do? Did policies, controlled applications by interfacing with configuration interfaces of the network appliances. What it really does is simplifies, at least it's supposed to simplify, a complex network. What's the main difference between a NAS and a SAN?
Between a NAS and a SAN.
Network attached storage and storage area network.
Network attached storage and storage.
Say it again.
It's a network attached storage and a storage network.
Yep.
Area network.
Yeah. What's the main differences?
What is it, the file and the non?
Yeah, well, yeah, they say, and from a technical standpoint, it's the file level access or the block level access. They say, and this may be one of the ones that's the CompTIA answer, is that network attached storage, typically a single appliance providing file level access, so that's the technical difference. In a storage area network, block level access to multiple storage devices. And that's what these pictures here hopefully do show. What would be a key difference between purchasing a cloud web server instances and a virtual hosted server? What are the advantage here?
Private and public?
Well, how about elasticity? If we purchased the web server or the software as a service, it'd be much easier to say, hey, we need more. We need another site. But if you purchased the server, you can always get more memory and more disk and things like that. But if you needed another server, then you got to go buy another server from them. What type of network infrastructure could be located off-site using network as a service? If you were a company.
VDI.
Huh?
VDI.
That's one of the things with things like what they say, e-commerce, web servers, corporate LAN, all those things. We could actually offload all of our networking, and a number of people are doing that because it reduces the number of people that they have to buy. So, you look at a cloud provider probably for the jobs, but a small company that needs a network, that may be part of the answer for them, so that they can continue to keep going without having to pay an exorbitant amount. Not so good for those of us who want to work in the industry, but that's a good. I've got a student who worked at a cloud provider and is working at a different cloud provider now in Atlanta. He said they pay really, really well, but it's also very, very demanding. So,
That's all.
huh?
Having
Having trouble hearing you, Tom. Yeah, you're breaking up a little bit. I think we've got some jitter.
Basically, offload everything.
All of your packets are not being delivered.
Yeah, I mean you can hear it too. It sounds like it's some jitter, doesn't it?
Sound like a robot.
Yeah, that's what jitter. We'll make a presumption that everybody's back or nearly so. So what we want to do in this one, this is about how the buildings are set up, the wiring is set up, and it's called network sites, the way the site looks. So the objectives are specify and install elements of wiring distribution such as cabling, distribution frames, patch panels, and wall outlets, all kind of cool names, but how we going to make the data physically go from one location to the other. That's what we're talking about. Install and configure equipment in rack systems using best practices. Rack systems typically where your servers are going to be, and you can even have blade servers or rack servers that you would have in these systems. Configure power management and redundancy solutions and environmental monitoring and control. All these sound really long objectives, but these are things that a lot kind of makes sense, I think, I hope. Describe the use of physical security controls in planning and implementing site security, lock your doors. Summarize basic emergency procedures and key features of fire suppression systems. So wiring distribution, and I've tried to put some stuff in here and probably got some things in the way. We have the workstation, which goes into the wall outlet, and that's what this little jack over here is. This is if you haven't configured one of these things, this is what it looks like. It's got a mini punch down here, and they usually come with a little punch down tool that you punch the wire in. Based on the color code that's on the side of it, depending on whether you want the A standard or the B standard, depending on where you want to, A to A, B to B, straight through or crossover. This is what the end of the wire is going to look like, and I got this one because it shows the different colors. I don't know if it's the right or not. I can't really tell by the colors. It kind of looks like it is. But this goes into the wall, which is this thing here, and then runs over to the patch panel or the punch down block, and this is going to be the punch down block. This is going to be a 110 block. The 66 blocks are for telephone systems that are older. The 110 blocks are for networking, and then we're going to have the front of it's going to look like this, and we can take the patch cords out of here and go into the switches that we're going to use, and that's the switch down here. Plug it into the switches into the correct port on the switch. The wiring standards, the TIA, EIA 568, and we have the 568A and the 568B, and if you want a straight through cable, you have the same standard on each end. If you want a crossover, one of them has to be an A and one of them has to be a B. When you start doing these things, you need to maintain consistency. And as you saw from the receptacle, you can wire it for either the A or the B standard, depending on which one you're using for your RJ45 connectors. They say that the return on investment on an infrastructure should last 10 to 15 years. I think the book actually says that should last about 10 years. So the infrastructure is going to be there for a while. You need to take care when you put it in. And the legal regulations that you have to comply with, building codes, electrical safety, all those things, fire safety. And FCC regulations. FCC regulations, if you're transmitting. Fire safety, if you're, depending on how you're running the cable, if you're in a plenum, a place where air is transmitted, you have to use plenum cable, and honestly I think most of it is plenum cable today, and that includes places like overheads where they just put the air up and it comes down the vents in the overheads. A lot of buildings are just using the empty space above the false ceilings as the plenum, so you need to be careful. And the reason you need to do that is plenum cable doesn't burn with chlorine gas. The non-plenum can be really dangerous and can be dangerous to you and can be dangerous to firefighters, so those become an issue. The structured cabling system, and I've put some pictures in here, the topology, the horizontal cable shall be configured in a star topology. Each work area outlet is connected to a horizontal cross connect in the telecommunications room. That means that everything goes back to the network operations center, to the NOC. So the horizontal cable is called that because it normally resides on one floor. Connects to connects work areas to horizontal cross connects. Horizontal cross connects are these punch down blocks that we looked at earlier. The backbone cabling in this picture here is the backbone cabling connects horizontal cross connects. So it's going to connect high-speed segments of our network. Work area, network, and telephony ports, and the telecommunications room down here is where the equipment's going to be. The entrance facility is called the demarc, and the demarc is the area that marks the change of ownership from the provider to us, so that anything inside the demarc, if it goes wrong, we fix, and things outside the demarc, the ISP fixes. And administration of this thing, the cabling system has its own standards that we need to comply with when we do these things. Distribution frames, the main distribution frame is the area in the main part where everything is. The network operations center is where that's going to be. So it's where the equipment is, the equipment storage area is. An intermediate distribution frame is someplace else. It could be a switch in a room would be an intermediate distribution frame. It connects to the main distribution frame, but it's the one that actually goes to the access. When we talked about that, would be at the access level. It's where the machines are going to plug into. We have different punch down blocks. We have the 66 block, which are the older systems, and the 110 block, we have a picture of it here, which is the newer blocks that are used for networking. And then the patch panel is actually the other side of the punch down block, this thing here. And it is what we use is once we wire this stuff, we take it to this, take a jump or a patch cord from it to the switch port that it's going to go to. When you do these things, and I think there's a slide later on, probably the next one, talk about labeling. You need to label the wires. If you don't label the wires, you have no clue where it's coming from or at the other end where it's going. You got to label it at both ends. When you're pulling wire, put labels on the wire. I've been through a lot of mistakes over the years. The first time, and when you do the first time and you've never done it before and nobody's done a lot, and then you're early on in this thing, we pulled a bunch of wire and we had I think probably maybe 100 computers or 75 or 60 or something, a big number of computers in a room, and pulled a bunch of wire into the room, and then it's like, okay, where does the other end of this one go? So you take it back out, and you label it before you pull it through. And they also recommend color codes for the different types of, and there's a chart in the book that gives us a sample. That's not a requirement, but it is kind of a handy thing to have, color codes. So you know what kind of wire you got where, right?
Yes, sir. Because cabling can be a little difficult, but once you get it, you got it.
Yeah, and you also need I think you need a wire map in the notebook so that you can look up when the CEO's machine goes down, you know where to go to find out in the patch panel what's going on, one end to the other, so that you know which wires to check. And it's something that takes some time to get it right.
Yeah.
But once you get it right, you got it, right, Tamika?
Yes, sir.
I mean,
Somebody taught me, so, and I kind of know that. I don't know the wording of it, but I manually learned it. So
yeah. I mean, well, we learned it the hard way. When you don't have that wire map, and you go try to troubleshoot something.
man,
I got a machine. I know where it's plugged in. I have no clue where it goes. Now go find that wire. There are tools that you can do that with. A tone generator, you have to use a tone generator and go wire to wire to wire to try to find it.
Yep, I've used those. Very time consuming to do that.
Yes, it is. Yes, it is. But that's sometimes the only way to do it.
Yep.
Yep. Especially if somebody else put it in, you're going behind them.
Oh yeah. And that's one of the lessons for that is when you put it in like you're going to be there forever, and and you're not going to be, but do the next guy a favor.
Mm-hmm.
So that they got to start on it. The labeling, the administration standard and naming conventions for these location ID and the data port, the identity of the circuit with labels at both ends, network appliances and servers, and then the color coding is one of the things that's recommended. That's not a requirement, but you really do need to label these wires. I can't emphasize that enough because that's going to take so much time to find. If you don't have it, particularly if you got even a small network, it's going to take a long time to find a wire. Rack systems, and this is a picture of a rack system, and they're for secure dense storage. They've got locks on them, and they're going to be inside a locked network operations center. We would hope that it's going to be locked. There's standard widths and variable heights on these things, and we have server racks. We have the big racks like this one, and this is what a blade servers would plug into. We also have roll-in, slide-in racks for servers. 2-post, 4-post, and freestanding racks. There are a number of different ones, and you've got to get what fits in your system, and you put these things back to back. You don't put them front to back so that you get all the hot air. You can take all the hot air out from the system. And what they do in the large systems is they usually have them blow into a channel and then they ventilate from there. But when you start getting big systems and racks and things like that, you start running into heat issues unless you've got some way to carry the heat away, and that becomes a real significant issue. That's one of the things that virtualization helps, is to control the heat, because you have fewer physical machines, fewer heat generators in the systems. Rack installations, airflow, placement, and weight distribution. Be sure you put it in the right direction too. We put one in and then had to turn it. Actually, no, that was the punch panel to put it in a nice, really looked good. And then they decided to change things. You had to turn it around. That's always something that's there. Talk about cable slack. You need a little bit of cable slack. This punch down block here is really good. That's not what most of them look like. Many of them are just look like wild tangles, but when you do these things, they've got holders here for the wire to go in. Use that, and it will keep it nice and neat and makes the wire a lot easier to find when you do this. A little bit of slack. You don't want to pull them tight, because if you do, you're going to start pulling the wires out of the RJ45 ends. And when you do that, you start getting some inconsistent problems. Sometimes it works, sometimes it doesn't work, and you walk past it and it quits, and you walk past it and it starts again, or you touch it and it does work, doesn't work. Weight distribution, you need to be careful of that you don't have these things to where they're going to fall on you. They really do need to be mounted. They talk about tool safety and ESD. Tools, electrical safety, kind of like standard practices. When I was in the Navy and we were working on equipment, they only allowed us to use one hand at a time. And that was for the electrical safety, and that was even with the equipment turned off because we were working on radars. They stay charged for some time. But the reason for that is if you look at your body, if we have this guy, make this guy turn around, but if we have a charge to go through the body, it goes through the heart. And this is 60 cycle, generally 60 cycle electricity. And our heartbeats, if it was a 60, would be 60 times a minute, not 60 times a second. So that becomes a real hazard. Be careful when you work on these things. When you work on equipment, be sure it's turned off, unplugged, and discharged if it's something that has capacitors in it. Like if you happen to have a CRT, which you probably won't anymore, those need to be discharged because they can hold a charge for a long time. Power supplies can hold a charge for a long time. Typically, you're not going to work on them. You and I are not going to work on them. We're going to replace them and send them back. And be careful of safety hazard. Grounding, be sure that the systems are grounded. The NOCs tend to have probably a higher power deliveries than the standard 30 amp service because we have high powered equipment there. And remember, if we go back to the power over Ethernet switches, you're going to need enough power delivered out of those to power however many devices are attached to it. Be sure that you have grounds because that's going to help you a lot too. And then I went and found this little picture on proper lifting. I'm sure everybody knows, but they ask those kinds of questions. Lift with your knees, not with your back. And trust me, I've been there, done that, and at my age, it really hurts. Material safety data sheets are for hazardous materials, and you just need to know kind of what's in them. You can find those on the internet. Take a look at one, see what it looks like, just so that you have an idea. Electrostatic discharge is our enemy in the computer world and in the networking world and in the devices because the devices that we have use such small voltages and currents that anything can damage the devices. And when you get a short that you can feel, like when you're walking around in the winter when it's really dry and you touch the doorknob and it arcs, that's probably, I don't know, somewhere around 50,000 volts. You can damage electronic equipment with electrostatic discharge that you don't feel. So when you're working on equipment, you need to have a wrist strap, and all this is a strap that has a cable connected to it, and you connect it to the device. And what this does is bring you to the same potential. It doesn't matter what that potential is as long as it's the same so that we don't get the discharge. If you're both charged to 100 volts, that's okay. If you're both charged to ground, that's even better. If you don't have a wrist strap, put your bare skin on the metal frame of the device, and that will help. Probably be enough, but it's a lot easier to use the wrist straps. There are ankle straps and mats and all sorts of things that you can use to do these things with, but you need to be sure that you're not arcing and sparking onto the equipment. Power converters, a power supply, and this is a picture of an open power supply. You really shouldn't do that because they have capacitors in them. They can hold charges for a long time. They can become very dangerous. Power supplies generally considered what's called an FRU, a field replaceable unit. A power supply converts the AC to the DC. The computers don't use alternating current. They use direct current. And it was 3, 5, and 12 volts, I think, are what's used in there. So the power supplies are available, and big servers or even small servers will frequently have two power supplies in them for redundancy. If one of them goes down, then the other one continues to work and the server doesn't go offline, doesn't crash. Servers are a big deal, obviously, because that's the thing that's where we've got all the information that we're trying to share with people. The other thing that we show here is a power distribution unit, and this is a really small one. We had one in the last place I worked, and it was a huge cabinet, and what it does is maintain steady power. It filters the power so that you don't have the bumps and bruises, the ups and downs of power in your system, in your critical infrastructure. High amp for data centers and equipment rooms. The PDUs provide line filtering, which means it's going to have steady power, at least we hope. And there can also be monitoring functions that go on in this thing, what's going on with the power. Clean power is what we would really talk about. Uninterruptible power supply is typically going to be a battery bank. And for a large system, it's going to be a battery bank that has enough battery power to fail over to allow a standby generator to activate. And those are pretty neat. If the power goes off, the batteries take over and the generator starts, and then the generator takes over. And you don't even know that you've lost power when you do these things. But you need to, on the UPSs, check them, maintain checks on them, because it's pretty embarrassing when the power goes off and your UPS battery's dead and everything dies. And that does happen. It has monitoring. The UPSs, the standby power supplies, the generators can run things for a long time. UPSs generally are not designed to run the network for a long time. They're designed to allow you to do an orderly shutdown, because it really doesn't do you a whole lot of good to keep the servers up if everything else is down. So check on them. They have monitoring software for them. They have software that the servers can send signals to the UPSs, but monitor it, be sure that they actually continue to work. Temperature and humidity are a big deal. Temperature, I think it says 60 to 75 degrees is where we should be. You don't want it too hot and you don't want it too cold. Too hot's going to affect the electronics of the system. Too cold can affect those items that have moving parts, discs, fans, those sorts of things. You want to have the air filtered. Dust is a real killer on systems, and you really don't want smokers around your machines, because the nicotine gets on the surfaces and can cause problems with connectivity when we do them. Environmental monitoring tools, you can do per room, per rack, per device, but what are the temperatures? What's going on? And then the per rack, we talked about carrying heat away. The ability to carry heat away. Is the heat being carried away? How hot are any of these things? And then a per device, a lot of them already do their own measuring, and you can monitor it with software. How hot's the CPU? How hot's the internal case temperature of the server? Those are things that can become significant because they can take themselves offline pretty quickly. This is talking about device placement and airflow. You need to be able to have airflow to bring the cool air down here at the bottom coming in and the hot air going out. So device placement can be important in those things. Hot aisle consignment design, this is by Keyzone, and there are a number of pictures that you can look at on how to design these things so that they work. Physical security, different zones. External, and this one, external is outside of the company, out here. Out here somewhere going to be external, and then the perimeter is going to be the areas around the building. Public up here where anybody can be, the public area, you go into a business, the reception area, places like that. Restricted area is going to be out here in the pink area where most of the employees are going to be, because we don't want just anybody being able to go back here. And then we have secure areas where only certain individuals can go. And you have to have some sort of controls on these. You can have fobs. People go to those things. Badges with proximity readers on them. People that work in IT typically can get anywhere. I had one place I worked where IT could go anywhere, and they would use people always used to love to get on the elevator with us because we're the only ones that could get to the basement, and the basement had a shortcut to the parking lot. But physical security is really one of the bases for protecting your network. Who can get into places? Are the computers unsupervised? If they are, the room's locked when they're unsupervised. Because if you can get physical access to machines, you can do an awful lot to them. If I can get physical access to the machine, I can probably boot it. And then if I boot it, I can go in and change passwords, get into the system, make myself an administrator, do a number of different things that we may or may not want users to be able to do. And how do you maintain physical security? And these are some of the things. Door access controls, conventional and deadbolt locks, keypad ciphers, token proximity readers, and a biometric lock. Turnstiles and man traps. This is when you see you're talking about a man trap. What a man trap is, you have one door that you go in, and then the lock, and you go out. And they had something that kind of happened here a few days ago. We had a bank that had an entrance like that, and somebody was trying to rob the bank, and they had a gun out as they went in here, so they got into this door and they locked this door so that they couldn't get in, and they've called the police, and they came in and arrested them. But man traps, you get people in areas that you can check the security. Turnstiles help a little bit. You want everybody, when you're badged area, everybody to use their own access. These locks here, yeah, they're really cool. Tailgating, though, somebody punches in the numbers, opens the door, and then they go in, and somebody goes right in behind them. They call that tailgating. Those things happen. Or if you're really nice, somebody's dressed in a UPS uniform, you let them in. Or somebody's got a bunch of packages, you open the door and let them in. You let them in an area where they shouldn't be, so you need to really be aware of those kinds of things. I always thought, and I lobbied for a long time on the knock so that you don't leave it unlocked, as you have a system that you have key entry and you don't have the ability to unlock it from the inside. You can get out, but you don't have the ability to set it as unlocked where it can be unlocked from the outside. And those are one way, and there's a number of those things that are available. And then an automatic door closer so that the door can't be left open. Those systems need to be protected all the time. And the other thing here is fail safe open and fail secure closed. How you set the system up. If you lose the power, what is the fail safe? How are these things going to fail when we get there? We're getting there. The security guards and video monitoring are also important. Cameras, CCTV, that's becoming bigger and bigger and bigger deal, and it's becoming cheaper and cheaper and cheaper so that you can monitor what goes on in the system, what goes on in the building. what do you want to watch, and you need to do some calculation as to how many cameras you want, how many cameras can you monitor, and where do you want the cameras, what sort of activity do you want to monitor in those things. The IP cameras the systems are not nearly as difficult to install nor as expensive to install as they used to be. Fire prevention, kind of a big deal. Building layout and emergency alert system. How's the building set up? It needs to be set up to prevent the spread of the fire and allow easy access for the individuals. They also need to know how to get out and practice getting out. Warning for the occupants and alert the fire department how we're going to do escape plans, routes, and drills are things that really need to be done in a fire in the fire prevention, because what we first thing we want to protect is the people, because if you don't have the people, you don't really have a business anymore. So those things all need to be practiced. The building layout and preventing the spread of fires. Are there fire doors? How are you going to try to do that? And does the building allow easy exit in the case of an emergency? And are there enough exits? And that's where the practicing comes in with the drills. Does everybody go to one door and create a bottleneck so that they can't get out, or are there multiple paths to get out of the building? And the fire systems themselves, and I put this picture over here of the fire triangle. The fire triangle is oxygen, heat, and fuel, obviously. A few years ago, actually many years ago now, I guess, they started talking about, over here called chain reaction, but at the time they called it free radicals, which also supported the fire, which if you suppressed would help put the fire out. But we need these three elements, oxygen, heat, and fuel, in order for the system, for the fire to burn. So it's the fire triangle. Fire classes and extinguisher types, and you can, this is in the book, A, B, C, D, and K. A is ordinary combustibles, paper, wood, and it's going to be white smoke. The symbol, green triangle. B, class Bravo fire. The color, these are the color of the extinguisher, silver, and they're going to be red. The symbol's a red square. It's flammable liquids, oils, paints, alcohol, those sorts of things. And it's going to be black smoke. Class C, the color of it's going to be red, and the symbol's a blue circle, electrical equipment. CO2 is going to be the standard to do these things. And you need to be sure that you have turned the power off on these things. Class D, combustible metals, and Class K is something that I guess been around for a while, but I missed it for a long time. There are highly flammable materials such as cooking oils or fats. And there, again, we have the color, the extinguisher is going to be red, and the symbol is a black hexagon. So fire and fire systems. Sprinkler systems, we can have a wet system or a dry system. A dry system means that there's no water in the sprinkler until it activates. A wet system has water to the sprinkler head. The dry system is going to start a little bit slower than the wet system. Wet systems need to be flushed occasionally. If they're not and you use them, it's going to be a real mess. It's going to be a big enough mess as it is. And you need to be aware where the sprinklers heads are, because if you're fighting a fire with in your NOC, you're probably not going to want sprinklers, water going all over your servers. There are safe systems. Halon was really good for a while, but then they found out that it does something bad, and there are other systems that replace it now that are safe fire control systems. CO2 flooding systems are really dangerous because they kill people. So you need to be careful, and there has to be a warning system and a delay to allow people to get out of the area if you use those types of systems. But they're there, and fire safety, something that is important to us because There's a lot of equipment that we have in there. So the review of this one is specify and install elements of wiring distribution such as cabling distribution, frames, patch panels, and wall outlets, and we looked at those briefly. Install and configure equipment in the rack system using the best practices, depending on what kind of racks that you use. But you need to get the racks that fit your equipment, obviously. Configure power management and redundancy solutions and environmental monitoring and control so that we don't get it too hot, too cold, filtered air, those kinds of things. And you need a backup. We had the cooling system in the NOC fail several times, and they bring in a portable AC, and you need to know where to get those just in case you do have and you don't have redundancy, you do have a system failure. The use of physical security controls and then the basic emergency procedures. So with that, see if we can do these, because they can have a bunch of questions here because these are the ones that are easy. What role do cross connects play in structured cabling systems? And we can't be done until we get the questions done. Going. Say again?
Horizontal.
Horizontal. I heard that. Yep. Horizontal cross connect, right?
Yes, sir.
What would be a typical use of an IDF? Yeah, I think Tom's got it, but he's still hard to hear. But yes, an IDF actually connects to the MDF, and it connects the backbone cabling in the multi-building and the intermediate distribution, intermediate distribution frame. And I had heard it as, and you may hear it as intermediate distribution facility, as well as the main distribution facility. Introduces a hierarchy of cable organization between the MDF and the horizontal cross connects. What's a 110 block?
That's the
Yes. I can kind of hear you out. It terminates the cabling at the back panel of the patch panel. It's the punch down block that we connect to that goes to for the patch panel. You're working at a telecommunications point and notice that cables in one patch panel are all red while the ones in the other are all blue. What, if anything, does it represent?
Dang, I know this one. Oh my God. I am so mad at myself.
red is work area telephone links,
Yeah.
and blue is work area data links.
Yeah. And that's what that recommended table is in the book, right? Is that where you're getting that intro?
Yes.
Yeah. Well, I mean, there's no reason that you would know that. It means that you've color coded your cables, and those are the recommended colors, and they're not the colors that you have to use, although probably on the test are the ones you'd have to use.
There's another saying for it though. But
Say again?
nothing. I learned it a different way, but go ahead. Let's go.
She just wants to get done. True or false? Rack units are sold in models of varying width.
False.
False. There's standard width and varying heights.
Contact. They might.
You may need to log off and log back on.
That may or may not work. We're almost done, so it's kind of not now.
Pointless.
Yeah. Rack units are sold in models of varying width. False. 19-inch width is standard while the height varies in U units of 1.75 inches. You need to install a mixture of 1U servers and switches and 4U servers in single rack. Would a 4 or a 2-post rack be most suitable?
Relative.
A 4, wouldn't it?
Yeah, 4, yeah. 4 posts where devices are secured at the front and back would be required to cope with the heavier 4U units and the overall volume of units being installed. What is cable management?
Making sure that all the cables are installed correctly.
Yeah, so you don't have spaghetti.
Yeah, forget it. Exactly.
You guys have never seen one like that, have you?
Yes,
I have. Yes, I
have.
have.
Oh yeah, I have too. We had one like that, and it took many weekends in order to sort it out.
Really a whole.
True or false, an ESD wrist strap is designed to provide a personal ground to protect the technician from electrocution when working on energized electrical devices.
False.
False. As a matter of fact, it would probably help get you electrocuted if you're working on an energized device, and don't work on energized devices. It's to prevent electrostatic discharge. What rack mountable device can provide a line filtering and power monitoring feature?
You.
PDU, power distribution unit. Where was that thing? Here it is. What type of door access control would allow entry based on possession of a cryptographic smart card?
Man trap?
Man trap. Now, it's going to read it. It's going to be a proximity. Did you say proximity, Tom?
No.
I thought somebody did. It's a proximity reader. You can have them in the badges, and when you get close to it or you wave it in front of it, it opens the door or unlocks the lock. Actually, it opens the door, and then you can open the door. Now, this is yours, Tamika. What type of door access control prevents tailgating?
Man trap.
I wanted her to answer it.
It makes me sick. Okay, Andrew.
You were taking too long. We trying to go.
I know you're ready to go. Get out and leave.
You at home already. I still got to drive.
Oh my God.
What technology could be used to provision security cameras without having to provide a separate circuit of electrical power?
Cloud?
How about, huh?
POE.
PoE. Exactly. Power over Ethernet. What are the main elements of fire emergency procedures?
Escape plan? No.
Yeah.
Oh,
Escape
okay.
plan, routes and drills. Okay.
Yeah, drills, exits, building layout, door locking mechanisms so that you can get out. You can't lock people in the building. You can lock people out of the building. Fire detection, alarms, escape plans tested regularly, the drills, all the things that you said.
That's number 10.
Number 10, is that what he said? I think.
Mm-hmm.
Let me.
Rack arrangements.
Oh yeah, we skipped that one.
Oh, did we?
Yeah.
Okay. What rack arrangement makes HVAC systems in a data center work more efficiently?
That's the one with the picture you showed us.
Yeah, that's the hot aisle, cold aisle. That's where you put them back to back so that you have hot aisles, which are the back, which is where the stuff's going to blow out of.
What's the
And
name?
the
What's the
hot
name
aisle,
for it?
cold aisle is what it's called. Servers are placed back to back, not front to back, so that the warm exhaust from one bank of servers is not forming the intake air for the other ones. And if you think about it, that makes sense, so that you don't blow the hot air of one machine into the intake of the other machine so that it becomes even hotter. So you put them up back to back, back to back. So, and that creates the hot aisle.
We're done. We're finishing up, yeah.
Questions?
No, sir.
Now, if it offends you